A number so perfect we find it everywhere, linking art to architecture to living things to literal galaxies. Today, we're going to talk about the golden ratio. The golden ratio is defined as the ratio of two numbers where the larger one divided by the smaller one is equal to their sum divided by the larger one. It's equal to 1 plus the square root of 5 over 2, and it's often represented by the Greek letter phi. Phi has some pretty unique mathematical properties. Phi is equal to 1 plus 1 over phi, and phi squared equals phi plus 1. We can use it to make something called a golden rectangle, a rectangle whose side lengths are in the ratio of phi. They're unique in this way. If you take a square off the side of a golden rectangle, you still have a golden rectangle. Phi also shows up as the ratio of consecutive numbers of the Fibonacci sequence. 8 divided by 5 is 1.6, and as we go further down the sequence, we're going to get closer and closer. Phi shows up in geometry as well. Take a look at this pentagram. This ratio is equal to phi, and so is this one, and so is this one. Phi has this reputation as being one of the secret building blocks of the universe. It supposedly shows up in art and architecture and in nature, from creatures like the tiny Nautilus all the way to giant spiral galaxies. But here's the thing, most of these claims simply aren't true. Nautiluses have a wide range of measurements, some of which happen to approximate the golden ratio. There is no evidence that the Egyptians or the Greeks would have had the knowledge or the inclination to use the golden ratio in these constructions. Da Vinci's writings suggest he had no intention to use the golden ratio with the Mona Lisa. So does the golden ratio actually appear in nature at all? Yes. Imagine that you're a sunflower. You're sprouting florets and you want to get each spaced out as far from the rest as you can to give each one the best chance to grow in your limited space. Over millions of years, you've evolved so that each floret emerges 137.5 degrees from the last one, a measure known as the golden angle. And look, when you're done, you'll have this beautiful spiral pattern. If we count the spirals going one direction and divide by the spirals going the other direction, you know what we're going to find? Phi. And we'll see the same property in pine cones, pineapples, roses, daisies, artichokes, and many more. That's all for the day. Till next time.